So here are the solutions. I will post them on Blackboard as well. Okay. All right, so for the first one, okay, we're going to factor that. And hopefully you can see that the GCF for this one is 1. I mean, although it might have been the other class I said it, but the GCF is 1, mostly because there's a non-zero constant term. So you can't factor out x at all. The leading coefficient is 1. And so the only common factor among the coefficients and the constant term is 1. So basically the GCF would be 1 times x to the 0, which is just 1, of course. Although x to the 0, again, is not that precise, just gives you a way of remembering. So the GCF for this is 1. So what we want then are two numbers whose product is 30 and whose sum is negative 17. And as you can see here, negative 15 and negative 2 are going to work. Again, that's because the product is 30 and the sum is negative 17. So again, for number 1, we have negative 15 and negative 2. That's what we use. Okay, good. All right, let's see, we have that. Okay, so that's for number 1. For number 2, again, the GCF is still 1. Here, we want to find two numbers whose product is 3 and the sum is 2. Well, it turns out no numbers do that, right? Because for 3, if you do 3 times 1, that's just going to give you 3, but that sum is not 2. Same thing with negative 3 and negative 1. Because again, the sum is not 2, the sum is negative 2. So unfortunately, that one doesn't work either. Why is this? There we go. All right, so that doesn't work either. Okay. So because there are no two numbers are going to work, and that tells us this polynomial cannot be factored. It's not factorable. Are there any questions about that? Yes?
So for that one, could you not do x plus 3 and then x minus 1 to get 2x?
No, because 3 times negative 1 is negative 3.
Oh, okay, okay.
Okay. That's a good question. So awesome. Any other good question? Any other questions? I mean, if this was minus 3, then that would work, but this is plus 3, so. Right. For the next one below it, x squared minus 4x plus 24, same idea, right? So we want two numbers whose product is 24 and the sum is negative 4. Two integers whose product is 24 and the sum is negative 4. Well, okay, what about 2 and 12? That doesn't work, right? Their sum is 14, not negative 4. Same thing with negative 2 and negative 12, right? That doesn't work either. 4 and 6 doesn't work, right? Because the sum is 10. Negative 4 and negative 6 don't work. Same thing with 8 and 3 and negative 8, negative 3. So no pair of integers are gonna work. There's no pair of integers whose product is 24, but the sum is negative 4. So that's also not factorable. Okay, I hope that one, are there any questions on that one? Okay, let's keep going. Number 4 is below. Number 4, notice, although I think I mentioned it, you can actually factor out the GCF from this. How do we know that? Well, for one thing, each term has a common factor of x, right? There's an x in each term. So right away, that's going to tell you, oh, the GCF is not just 1. Now, the smallest, as you can see, the smallest exponent of x is 2, right? So if you went back to that b times x to the m notation that we did, the m would be 2. Now 3, the only factors of 3, the leading coefficient here, are 1 and 3, right? 3 is that a special kind of number. It's what we call prime. Its only factors are 1 and itself. Integers greater than 1 that have that property are prime. But 3 is a factor of 42 and 72. So the greatest common factor among the coefficients is 3. And so the GCF is 3 times x squared. Now, once we do that, though, we have to factor it out. How do you factor it out? You divide. That's what I'm doing here. You know, when you divide, right, you have to divide into each term. That's just what you have to do, and that's what we're doing. And when you do that, we're left with 3x squared times x squared plus 14x plus 24. Now, are we done with this? No, we have to see, is x squared plus 14x plus 24, can that be factored? Well, it turns out that yeah, because, well, we want two numbers whose product is 24 and the sum is 14. Two numbers whose product is 24 and the sum is 14. Well, 10 and, excuse me, not 10 and 4. I almost said 10 and 4, but that doesn't work actually, because 10 times 4 is not 24, but 12 and 2 work, right? You know, it might take a little trial and error to find a pair of integers. That can happen. But 12 and 2 are going to work, right? Their product is 24. Their sum is 14, so it works. So we get x squared plus 14x plus 24. We get that that's equal to x plus 12 times x plus 2. It follows then that the factorization is the GCF 3x squared times x plus 12 times x plus 2. So that's what we get. Good. All right. That's number 4. Are there any questions on that? Okay. For 5, it's really the same idea, right? We can see that there's an x among each term, so the GCF is not going to be just 1. The smallest exponent of x is 3. Okay. 5 is also one of those numbers where its only factors are 1 and itself. And 5 is a factor, though, of 50 and 120. So 5 is a factor of itself of 50 and 120. So the greatest common factor among the coefficients is 5. So the GCF is 5 times x cubed. So that's good. Okay, that's good. Now we factor it out, right? That's what I'm doing here. Put it in front, divide to see what's left over, and we get this. And now we have to factor x squared plus 10x plus 24. Right? That's the polynomial left over. But okay, so to do that, we need two numbers, right, whose product is 24. The sum is 10. And what numbers do that? Well, 6 and 4, right? The product of 6 and 4 is 24. The sum is 10. So because of that, we use 6 and 4, so we get x squared plus 10x plus 24 is x plus 6 times x plus 4. And now we put everything together, so to say. We factor it out. We get the GCF 5x cubed times x squared plus 10x plus 24. And so we get this, 5x squared plus times x plus 6 times x plus 4. That's good. And finally, we have number 6 here. For 6, right? As you can see, the smallest exponent of x is 1. So the GCF is not going to be 1. It's going to have at least x in it. But notice the leading coefficient's 1, right? Well, the only factor of 1 is 1 itself. So the only common factor among the coefficients is 1. So the greatest common factor among the coefficients must be 1, and so the GCF is 1 times x, which is x. And again, once you get the GCF, you have to factor it out, and that's what I'm doing here. Okay? So we get x times x squared plus 25x plus 24. And so to factor the polynomial left over, what do we get? Well, excuse me, how do we do that? That's what I meant to say. How do we factor that? Well, we want two numbers, right? This is a trinomial. Here, hold on, let me get to that. Right? We have a trinomial of degree 2, leading coefficient 1. So we want two numbers whose product is 24 and the sum is 25. Well, hopefully, even if it wasn't on the worksheet, even if the solutions were not here, hopefully you can see that's 1 and 24. Their product is 24, their sum is 25. So we end up with this. And all together, putting it all together, we get 5x cubed. No, not 5x cubed, excuse me, that should be x. Sorry. I missed this. Whoa, sorry. It should be x times x plus 1 times x plus 24. Yeah, I gotta fix that. I'll fix the solutions, but hopefully, I hope it still makes sense. So, oh my goodness. Any questions on that? Let me just quickly do this. All right. If there are no other questions, I guess we'll have to stop now. So let me stop the recording.